Our machine age is made possible by cutting tools and by the men who understand the correct action, use, and care of cutting tools. This skilled craftsman is shaping a piece of steel with a single point side cutting tool. All single point cutting tools are made from blanks of special steel. A side cutting tool is formed by grinding first the side which forms the cutting edge. Next, the nose is formed. Then the radius, which removes the sharp corner between the cutting edge and the nose. Then the side rake, forming the angle of the cutting edge, and back rake are ground. Here is the tool in its finished shape, showing the relationships of the various sides and angles. The cutting edge, the nose and radius, the heel, the side and back rake, the side face, the body or shank, the base or bottom. This cutting tool or bit is inserted and clamped in a holder with a tight working fit. And the holder must fit the tool post. The tool is set on center and clamped tightly in place. And then moved into the work. The cutting tool stands still and cuts off the chip as the metal turns past it. The turning metal presses down on the point of the cutting tool. Let's study this pressure. When the point of the tool is set on a line with the center of the work, the work turns and the pressure is straight down on the point. The machine and the cutting tool setup are built for this straight down pressure. When the point of the tool is set below the center of the work, the work turns and presses down and in. Tending to pull the tool into the work. When the point of the tool is set above the center line, the work turns and presses down and out, tending to drive the tool away from the work. However, any pressure on any tool in any position generates a tremendous amount of heat. Let's observe the smooth flowing cutting action of a well-ground tool, first at normal speed. The chip flows across the top of the tool. This rubbing or friction generates heat. Now at slow lathe speed, notice that the point of the tool is covered by the moving metal. Now at slow camera motion, notice the chip is bent sharply at the cutting edge. This bending, like the constant bending of a wire, generates more heat. Here's the action from a different angle. The faster the turning, the faster the chip flows. The more the friction, the more the heat. Some of the heat goes into the work, some goes into the chip, but the hottest point is at the cutting edge. Therefore, there must be enough support to carry away or dissipate the heat. The tool is ground to eliminate as much heat as possible and to carry off the heat that cannot be eliminated. The angle at the top and side of the cutting edge reduce rubbing, friction, and bending. These angles must not be too sharp, since enough metal must be left to carry off the heat and to support the cutting edge. Too much heat at the cutting edge will ruin the edge. The tool will not work efficiently, and the work may be ruined. Or, most of the heat from cutting metal is collected at the cutting edge. Notice the smoke when a drop of oil is dropped on this cutting tool. The control of heat is the most important problem in cutting tools. When tools are not ground correctly, heat collects, breaks down the cutting edge, and batters the work. This is an example of what happens when there is too much heat generated at the cutting edge. The heat generated at this cutting edge is carried away through the tool body, holder, into the tool post, into the compound rest. In fact, the whole lathe acts as a cooling system for the heat generated at the cutting edge of the tool. On the right side is the standard side cutting tool. On the left is a side cutting tool with a groove or chip breaker. This chip breaker causes the chip to curl tightly and break and makes the chip easier to handle. It also reduces heat, since there is less surface in contact with the metal. Notice that because the chip leaves the tool more quickly, less heat is generated at the point of the tool. Also notice that the side and bottom of the tool clear the work in exactly the same manner as the standard cutting tool. The well-ground tool has the correct angles to reduce friction with the work and with the chip, provides enough adequate support for the cutting edge, and enough metal to carry away the heat. Correctly ground cutting tools, and the men who understand the action, use, and care of those cutting tools make our machine age possible.